we get spent at the machine, go over the machine, and start actually using it. And today I want to start a calibration job. So when we come in the morning, we can break it out, and we've actually take the measurements, make sure everything's good. Because you should do that for each time you change materials. Now, if you change materials and you've done that, you don't need to do it again. The only time I recommend doing it again is if you build something and you notice something isn't right. Maybe something happened. So then I would recommend going in and do another calibration job. But once you do it one time, you're good to go. And I'm pretty sure you guys haven't done it for MS1, right? So, like I said, I'm just going to quick go through these. The main objective of the bottom line is we want everybody to run the machine safely. Need to have an STL and the basic knowledge of, for a successful build, using Magics. We already did the safety. I will leave all safety, all PowerPoints, any documents you see here, I'll leave a digital copy behind. I'll have it on a USB. Real quick, we talked about what 3D printing is. It's a layer by layer process. On the 280, 290 EOS machine, it goes from right to left. Pushes fresh powder on, you got your laser exposed. And it does that until it hits your determined height. You have for components of the EOS machine, you got the mechanics, you got the optics, you got the pneumatics, you got the electrical. Front of the machine here, this is basically 290, which is just very similar to the 280. There's a couple of differences. But the recorder goes from right to left. The collector system, which collects the excess of powder, goes down, and it goes down with your build. So if you set it up just right, you'll never overfill your collector side. And the dispenser goes down with each consecutive layer, and then your dispenser layer goes up to disperse, so you can gather the fresh powder. Inside the optics, you have your fiber optic, you got your collimator, your beam expander, your scanner, and then on your system, you guys don't have a camera. Just another view of it. Main thing to keep in mind here is I always tell everybody, even though it says your focal laser focus is the top of your build plate. In theory, it's still going to go 2 layers into below that. So in theory, it's doing 3 layers. You guys have the wet separator, you have the chiller, you don't have the door, and you guys do have a shot tuned, or you didn't have a shot tuned?
We don't. We're looking at the laboratory
tumbler. Okay, because I still have to get you guys a list. Dr. Shusak can submit them a list. I'm going to submit a list of like a low end, high end, and then you guys can pick what you need, and then if you need help from us, we can direct you a certain direction too. A couple things, we'll talk about it, later, but the battery tumbler, it's okay, but it's really doesn't do a whole lot. But we'll discuss that in more detail in a bit. But I will get a list together of recommendations for you guys.
To improve.
Yep. Because you're going to need something for post-processing. You guys don't have any of this IPCM extras? Who knows? Maybe you guys are producing a lot. You get some funding from somebody. This is stuff I would recommend, especially if you guys start printing a lot.
The seed molecules will be amazing.
Yeah. This saves...
To collect the material from the building ground.
Saves a ton of work. Saves a ton of work, and then it also saves you guys from handling being exposed to the powder. You need an STL to complete your part. The actual process sequence that EOS uses, you got your CAD data, you prepare the data, you set up your machine, you build your parts, you take the machine out of operation, and you pack, and post-treat the parts. That is the process and sequence. Data preparation, you take your CAD, put it into Magix, you orientate it, put your build support on there. You guys, the 280 does not use the EOS Print 2. Skip that part, but you still submit the building task, send it to the machine, you start to build, and then you guys there are some softwares, there's EOS State, EOS Access that you can use to help monitor the build. And the EOS State also can pull reports on your job. Sometimes you'll have a customer that asks for a report on the build. So yeah, basically STL, CLI, OpenJZ, send the task. Magix, we will get into more detail with Magix either later today or definitely during the week. But the basic theme, you load your part. First you load the scene. I'll see how your guys' is set up. I'll have the scene default to your M280, so you don't even have to load the scene. You load your part, you orientate your part, you position your part, you repair the part, you make sure you save the STL, because after you make your changes to it, and if you don't save that, then you go to bring that STL and it's going to be the old orientation. You need to save it so it's the new orientation. Generate any supports if necessary. You're going to export it as a CLI file, and then you make any edits, and then you want to save the project. And that's one thing I need to look at on your Magix is if you have RP tools or if you're using the build process. I'll have to look at that. Because there's two different ways of slicing the file.
Yeah, I think we're using the build process here.
You use the build process?
We don't have the license.
You don't have RP, okay. I couldn't remember. So I'll go over that with you, how to use the build processor in Magix. We'll skip EOS Print 2. When we set up the machine and everything and heat the build plate, I'll show you how to check the recorder blade. Make sure that first layer is good, how to clean the lens. I think some of you have been through the class, so it'll be a refresher for you. So, pour the powder in, and if you remember from safety, it's important, don't swirl the powder up or cause, you don't want dust. Position the collector platform. I like to position that collector platform about 40 millimeters down from the top. That's a good height to start. It's not so low that when powder goes in over there, it's going to cause a little dust plume. And 40 millimeters also is a good number that if you start 40 millimeters low, the chance of you filling that too high and then causing a jam, is not going to happen. You check the recorder blade, you check it physically, and especially with the high-speed steel blade, it's extremely sharp. Going to MS1, you're using ceramic, so that edge is not as sharp, so you don't have to worry about checking it like with the fleshy side of the finger. But I still recommend you running the back of use the back of your fingernail is how I check it. Unfortunately with ceramic, if you do feel a chip in there, depending on how big that chip is, you're going to have to replace it.
So you say when you check it, is there any way to clean the edge of that?
Yeah, so you're going to look at it, you'll vacuum it off, you'll wipe it off, and then you're going to physically look for any chips. And then, like I said, I kind of take the back of my fingernail and rub, and you'll feel any chips or nicks or dings. With ceramic, it's going to be chips. And if the chip's too big, you're going to have to replace the blade. And I'll show you how to do that. Each blade is two-sided, so you got at least two uses of, you can flip it twice. After that, then you're going to have to put a new blade in there. And then depending on how small the chip is, you just wouldn't put a build in that spot.
Where did the chip come from?
The chip come from improper use. It could come from just during the whole building process, you got a part that's delaminating a little bit from your build plate, and so it's lifting, and so as the core comes across, it keeps hitting it and hitting it, eventually it's going to chip it. That's the only bad part with ceramic, it can chip it. And then the other part is too, is when you set it up, you're not careful and you accidentally hit your build plate, that can chip it too. You warm up your build plate. Each material set has a certain temperature that it will warm up to. It's automatic. You just say warm up build plate. As long as you got the correct material set, it's going to warm up your build plate to the proper temperature. Once you put your build plate in there, there is the leveling. It's the buttons on the front there that you're going to see. These are the only time you can actually move the platform with the door open. And this is what you would use to level the build plate. I'll go through the proper sequence of doing that. And this is probably one of the top 3 most important things you do. You want that first layer to be nice and level, and you want the proper amount of powder to be under that first layer. Because if you don't have enough powder, that's okay. But if you have too much powder, you're not going to get a good. That part's not going to adhere to the build plate real good. So you got a great chance of it delaminating, lifting, potential damage, ruining your build. And you'll see it's Y-axis and the X-axis for adjusting. I go into more detail when we're actually at the machine. And that's where it's showing you, setting up that first layer is very important. And then at the very end, you will clean the it's the F-theta lens they call it. You clean the laser lens. And I'll show you the proper way of cleaning that. I've already mentioned to Pablo. I think for training, the alcohol you guys have in there now will work, but you want to buy 99.99% pure alcohol, just so there's no residue as it dries. So we've loaded the build, now we start the build. Like I said, you can monitor the build, and if you do see something going wrong, you can actually pause the build. If you see something going wrong, doesn't mean your build is scrap and you got to start over. There are things you can do to pause the build, correct your errors, and start again. And if you have to, then you gotta, obviously send the build over. And then, like I said, EOS State will analyze your build. And EOS Access, same thing. So basically, EOS Access is what you use to adjust your time on the machine. If you have any license issues, EOS Access is what you will use. If you have any issues with the machine, EOS may say, hey, can you send us the log file? That's all going to be grabbed from EOS Access. Most likely, if you guys get on a maintenance schedule, you'll never need to update any kind of licenses. That will always be done when they come to do maintenance. Quick go through, I'm not going to read EOS State. I don't even know if you guys have it. I will check though. And again, you'll see EOS Access, you'll see the maintenance information, all your licenses, your parameter set, updating. Like again, you see this install patch, you should never have to do that if you're under maintenance. That's always going to be done with your, when they come in. Taking the machine out of operation, you guys are going to do the hand sieving. So you sieve, you remove the parts of the build platform, you clean the machine out with your wet separator. You will do the heat treat. MS1, unless you guys find it critical for material properties, you probably don't need to do heat treat. Now if you're doing something and you're doing material properties are important, you're doing some tension, strength, or you're doing some CT scans to see what the material, how dense the material, at that point, you will have to, you're gonna wanna do it as stress relief. I have it on the parameter sheet, I forget which standard it is, you're gonna follow an ASTM standard for heat treat. And it's, MS1, unfortunately, it's somewhat complicated, it's not as simple. Throw it in the oven for, like 650 for a couple hours, it's got a couple steps to it. Removing the support, again, at first you'll find that it's probably going to be difficult. As you guys get better and learn what you can do, it'll be easier. That's the goal you want it. You want it so you can pull it off with pliers. I have some practice parts we're going to be printing to show you what you want to strive for. But yeah, you're gonna want some kind of saw, wire EDM possibly. I'm gonna have that on the list for you guys, and you never know if you get the funding. That is what industry uses. Gives you your best results. But at the basic, you would want some kind of band saw. I don't know what you guys have now. And you got it. Is it got a deep enough, vise wide enough you can throw a 9-inch plate on there?
We can't chop it, it's not ideal, we're actually getting a new saw.
Okay. Because, hopefully you guys pick it up quick and you can get to the point where you can just manually remove your parts. But there are parts, sometimes they're just so big and you got so much support you just can't remove it manually. You gotta somehow get it off the build plate. That's just how it is. And then again, once you remove all your support, sometimes you're gonna have to have secondary, CNC machine, manual machine to remove that support from features that you just can't get off by hand. You want to do some kind of shot peen when you're done with it. That helps remove any excess of powder that's on the part. And then, you got grinding and polishing to help with the parents. So, like I said, later we will go through, do a little bit of magics. We will, I'll show you how to bring a task into the machine. On a 280, it's fairly simple. Just put it on a USB stick, is how it works on a 280. If you guys really wanted to, you could put a laptop in there and have a little standalone and send it to the, you can drop it into a folder to the machine, and then from the folder you got to open it up. So that's day 1. I'm going to just go straight into day 2. So basically this is going to be considered, I'm taking today as a day 2 training. So here is going to be our agenda. We're not going to take the machine out of operation, but we are going to set it up. We're going to spend some time on data preparation. We're going to load the task, and we're going to start a build today. Day 1 review, skip that. Don't think you have these wizards in the 280. Showing you magics again. We'll go into more detail with that. I will show a little bit of this, just an example of some supports. Rule of thumb, 45 degrees or less, you should have some support in there. Anything over 8 millimeters in diameter, and if you're going to drill that hole horizontally, you should put some support in there. And same thing with overhang structures, you should have support in there. Did we discuss this? So we'll just quick go through it. Like number 1 is just to hold the part. Support 1 is to hold the part on the build plate. Unfortunately, you have to have something. Support number 2, if you look at it, that is, you need to remove the heat from that thin layer that is building. You need to somehow remove the heat. So keep that in mind. Sometimes you'll build a part, you think, hey, I did a great job, I got very little support. It might not be the best way to do it because you don't have any way to get the heat out of the part that you're building. So when you pull the part out and you see it's all discolored, or it's severely warped, just keep in mind, hey, maybe I need to throw some extra support in there to help dissipate that heat.
Especially when you build the hollow points.
Correct.
And also the paddle is melted inside to the tube.
Yeah,
Between the
yeah, you'll run into it. Yeah, as soon as you see like a thin strip like that, you're gonna be like, unfortunately, you're gonna have to throw some extra support in there to dissipate that heat. So yes, you want the minimal support, but then there's times where you have to recognize the geometry of the part and say, okay, I need to pull heat away from that area. 3, you can see it's overhang structure. I'll show you magics how you can do an angled support like that. Because the last thing you want to do an angled support like that because you don't want to build support on top of your part, because now you're going to have 2 surfaces to clean up. 4, they're just saying, you want the support to be easy to remove. So there's things you can do in magics to make that support easy to remove, but yet it's still there to do its function. 5, they're just kind of showing you, if you can think about it, you don't need support like all the way up to the sides. You want to be able to remove any of the powder that could be trapped in there too. Once the powder goes through a heat cycle, you can't recycle that powder. Different types of supports. You got block. I'll be going into more detail with all this when we actually start using magics. A couple of the common features that you're going to use: XY offset, Z offset, no support offset. XY offset is just like it's showing you up there. You can set a distance how far away from the edge you want to keep it. A Z offset is how far you want the support to go into your part. The more you have it going into your part, the harder it is to remove. And you can also adjust the lower. No support offset. If you have a wall, you can actually tell it to stay away from that wall, making it easier to remove. That's the whole key. Is just how you're going to remove it. Block support has hatching in it. Default's 0.7 millimeters. You can go smaller than that, 0.6, 0.5. To me, anything lower than 0.5, you just might as well make it solid support because the spacing in between is very small after that point. Fragmentation helps from the fact that instead of trying to remove one big block of support, if you fragment it, you're going to have a bunch of smaller pieces that you are going to remove. Makes it much easier to remove. But at the same time, it also makes your support weaker, so you have to, what's the trade-off? Because at the end of the day, you want a successful part built, not one that, crashed or lifted up on you. And you have hatching teeth. You have, as you can see, there's a lot of numbers you can play around with to change your teeth. Ultimately, the thinner or the smaller you have that top length, the easier it is to remove the support from your part. We'll go through a couple examples later. And at any time when we pull up your magics, at any time you have questions what's going on the new magics, there's a little eye circle, just hover over it, and it will pop up a little example saying, okay, this is what ABC do. So if you change the numbers here, this is what it's going to affect on your support. Angled support. Here are some good default numbers, and I think this is where you guys' magic should be at these default numbers. Alright, so that's basically it for day 2. We'll come back in here later and probably look at some magics. But for now, we're going to spend the rest of our time this morning at the machine. Open it. These are where your filters are that you change. unfortunately this style, as soon as I open this, we're gonna have to pump everything down, so that's why I'm gonna leave it closed. When you do change the filters, you're gonna see a red light come on. I do recommend, if you have a short build, go ahead and finish it up. But after that build, do your filter change. It's not done by hours or anything. It's all sensed by flow. Once the flow hits a certain resistance, that will turn off. At the same time you replace the filter in there, you have a cartridge in here. It's in a little tube. Unscrew the tube, and it's got all your heavy waste powder in there. In your situation, they show you how to remove this with the water. So we were always taught to take these filters and put them like in a 55-gallon drum full of water. I don't know if they still teach. To me, I don't think they're teaching that anymore. Because they showed you taking the filter and putting it into a bag, tying the bag up, putting it in the box, and then calling hazmat. So what I would recommend doing is if there's not a whole lot of powder in there, at the same time you have your filter out and you have it all wet and everything, I would take that powder and just pour it on top of it. So make sure it's wet though. Don't pour the powder in here on top of a dry filter. Make sure that filter's wet, pour it on there. Make sure you screw that container back on there before you start it. And then I will actually call, and maybe they'll have a better recommendation what to do with that waste in there. So I'll actually find that out. Inside the machine, we come down. I'm going to go ahead and open it up. Again, you got your collector, your build, and your dispenser. Your quarter arm goes from left to right, or right to left. You have your lens. This is something, so you have the lens cover in here too. The one thing I like to do is, you're going to find it right here on, if you hit this adjust. See, there's a couple spots you can do it. I always like to turn the lens clean and nozzle bear on. So I click it there, you hear it click. You can either turn it on there, or under the adjust you can turn it on right here. And the reason I like to turn that on is when the door is shut, it's not sending any air across the lens. But when you open the door, it's sending air across the lens. So this way here, if you have powder, something, it won't stick to the lens. So when you clean the lens, you do want to make sure you go in there and turn that off, because that's going to dry your alcohol way too fast. But I want to show you how you take the lens cover off. That's how you take the cover off. Most of you should remember this. It's held up there with magnets. You'll feel it grab. So you pull it, push it up there, you'll give it a little rock. If it moves really nice, that means it's in there properly. If you go up there and you try to move it, it's not really moving. That means it's not sitting in there right. When it's sitting in there correctly, you should be able to move it and have a little motion. Okay. So remember, it goes in there like this. You'll have the third pin towards the back. Put it up in there. You feel the magnets grab. If you see how there's motion, I know it's right. So I want you guys come back, hit one at a time. Come up here, just grab it, go straight down. Kind of look at it. Get it back in there. You want to go straight, and you'll feel the magnets grab. Give it a little wiggle, because if you don't have it right, and you think you got it in there, it's happened to people. They'll start their build. Next thing you know, an hour later, the lens comes popping down. Then you got to stop it. You basically lose your build. Couple things you will notice on an M280. Sometimes there's some quirky things. Right now, if you notice, everything is grayed out. That's because the machine's kind of giving you a warning. They want you to come over here, and you want to hit this button. You're acknowledging I forget exactly what you're acknowledging, but you're allowing the machine. Now everything is showing you. So it's basically kind of just giving you a little warning. And that's on the timer. So if the machine just sat for a while, you'll see that goes back to green, and you're going to be over here. You're like, why can't I move anything? Just remember, come over here and acknowledge. So now at this point, I'm not going to hit anything, but you can move your recorder. You can either move it with the arrow, or if you hit the end position, it'll go all the way over. And then the only way to stop that is hit stop down here. So same thing with going back to the right. You can stop it. You can manually hold it and then let go. Or just let it go all the way. You have it's set at a slower speed. I recommend leaving it there, but you can go as high as 200, and you can see how much faster it goes once you get good. So when we actually do start a build, I'm not sure if it remembers, but when we start a build, we'll go to 200 just so it's not taking forever. But for training purposes, let me go back to 100. Every once in a while, if after a power outage or a power glitch, or sometimes the recorder just loses its home position, it's going to tell you that. And I think with this machine too, whenever you start a new build, it's going to ask you to home it. That is right here. You just hit that. Make sure you're all the way to the left. If you were to hit that when the recorder was on the right, it would slowly travel all the way over, and it potentially, if you have your build platform up, it will hit it. So make sure it's all the way to the left. Hit it. It's even reminding you, hey, make sure there's nothing in the way. And it's doing its little sequence. It just homed itself.
So when you start at the beginning, so that means home staging, right? This side is moving from.
Yes. So whenever we start a build, it's always going to be on the left side. I'll reiterate that when we start running. Whenever you're ready to go, the machine's pumped on. You're like, everything looks good. The recorder should always be to the left. Build platform, I'm actually going to home these. If you notice, our numbers are all grayed out. That's because I came in this morning, the machine was powered off. So whenever you power the machine down, you're going to have to home. It's not that critical to home these, but I like to kind of see the numbers and know what the numbers are. So we'll go ahead and home it. It just goes down and does this little limit switch, comes back up. And if you poke your head in there, you can see the build platform went down already. And you'll once it homes itself, I can't remember if this one. You'll see that the numbers will go black. The collector. The one all the way on the left. So it's homed itself, it's black, it's coming back up now.
Where the condensate will be. The collector.
Yeah, no, there should be, hopefully there's no, if everything's done right, there should be no condensate in the collector, just excess of powder. Should be no condensate in there.
The reason why?
Yeah, no condensate in there. So now you see everything is it's black. I also want to show you this, so let me bring that up.
So we would say to 40 millimeter, right?
So now it's all the way up, so you see your zero.
Yeah.
So here's where I like to, you can either do it manually. Remember I said that I like to start 40 millimeters down?
40.
So you can either do it manual, see the numbers, you get it roughly close to 40, or you can bring it all the way up, and you can actually do a step motion. You can do 40 millimeters there, and then make sure you hit the down arrow, and it's going to move its 40 millimeters.
Nice.
Build platform, same thing. We will we'll go ahead and click here again, you can speed that up. Up 5 is the fastest. So we'll just go ahead and hit home.
Home will be the higher point, right?
Yeah, so
The building platform, higher point.
so yeah, with the build platform, you saw it went up and then came back down. You see we have a little powder back there. And then the dispenser will do the same thing. Okay, so now everything is black, and at any time you can do step motions in these other areas. I like to come here, I want to clear that out so we don't accidentally hit that and move it. And then before I forget here, materials. So again, so you take your mouse, you double click down where you have your material, so it's MS1, we have speed in there, MS1 50, 100 speed. You come up here, you're going to load your default materials, you find the material you want, MS1. So you guys have 3 choices for your MS1. You have performance, which is, I meant to show you this in there. There's a parameter sheet. So performance is 20 microns, speed is 40 microns, and your top speed is 50 microns. For you guys, I recommend using the speed. When you get real good and you need high detail, you can use the performance. The 20 microns is real tricky because if you think about it, the powder is anywhere from 5 to 60 microns. A lot of friction going on there. So just highlight it, you say open. Now keep in mind, so let's say you decide 3 months down the road you guys want to run performance. You want your parts just to look a little bit better. Property wise, material properties, it shouldn't change anything. It's just changing the power of the laser. But appearance wise, you'll get a better looking part with performance because it's a finer layer, so you can just your detail is going to be better.
And the time also, the time taken is longer.
And it's taking longer because you're twice as, you're going from 40 to 20, so it's going to take twice as long. You got a lot more layers. But if you guys do that, remember you're going to have to run a calibration job for each time you change materials or layer heights. Once you do it once, you don't have to do it again. But so if you notice, you got 3 MS1s. So let's say you run all 3. That's 3 calibration jobs you're going to have to do. Alright, we'll set it up, we'll run speed, you'll be set. 3 months down the road, you guys decide you want to run performance, remember you're going to have to do a calibration job. You're going to run that cal job again, this time at 20 microns, because it's going to change your numbers. And that's going to affect dimensionally how your parts turn out. It's not going to affect your material properties, that's good. But dimensionally it will change because it's different power on the laser, so your melt, the way it melts, your melt pool is completely different, your beam offset will be different.
So you're saying the strength and the density of the material will change?
Same, won't change. It's just it's going to change the geometry of your part. Let's say you have a critical XY and you don't do a cal job, you pull the part out, it may not be within your tolerances. But I'll go into more detail on this. This is where you do your cal job, you double click that. This is where you change your scaling and your beam offset to make sure your part is good, or your cal job after you run your cal job, so your geometry, everything is good. You want your focus beam expander per part, not per layer. You guys get a little more experience, you may want it on layer, but you want it on part to begin with. A quick example of what that is so if you have a build plate full of 10 parts, If you have it on per layer, it's going to do each exposure per part, and then come back and do the next thing on the first part, do it all. But what potentially could happen is if you have it by per layer, it's going to do that. But then, so it does all its work, and then by the time it comes back to part one, that part could have cooled down. So then you're affecting your properties. So if you do it by per part, it's going to do all the work on that part, come over all the work on that part, so on and so on. It's not going to do a little bit of each and then come back to the first one. So you want it on per part to begin with, and then there's times where you may want it on per layer once you guys get a little more experience.
Quick question for this. You build something like flat at the beginning, and then you put like parties on the top of the layer. Does the system recognize as a part of those things, or?
Well, you don't
Per
really,
layer.
you don't want to, it would recognize it as a part, but you don't really, on a metal machine, you don't want to put a part and then parts on top of your part. You don't want to do that. So you have your part, you're going to want to arrange your other parts around that part. Yeah, you don't, 99% of the time you don't want to put it on top of your part like that. There's times you may do that, but like I said, 99% of the time you don't want to do that. Because now think about it, you're putting all that, you got a part on top of your part, now when it's doing the work on this part, it's putting all that heat back into the part underneath it. So you're gonna ruin your part underneath it. So a quick go through up here, this is your adjust screen. You have a machine tab here, so now everything is nicely highlighted. We've homed everything, so it's letting us know we're 40 millimeters below. It's kind of showing you that. Our dispenser platform, we're all the way down, showing you that. If we come over here and move that up, you'll see it changes. You can see the number change, you can see the color changing, showing you kind of where your platform is a little bit. Again, you can put in a 50 in there if you wanted. If you notice, if you wanted to see what your plate platform is going to go up to, it's 40C. So for MS1, that's what the plate temperature is. And if you notice, our plate is at 40C because I turned it on. And that also is in the adjust menu. Build platform heat right there. At 40C, I don't think it's really important to have that plate. You know, we put a new plate on there. Obviously, it's not going to be at 40C. But at 40C, that's not too much difference with the thermal expansion, so we can just tighten it. But there are like aluminum can go to 200C. That's a huge difference. You want to just put the plate on there, let that equalize, and then tighten the bolts. Does that make sense?
Yeah.
Okay. So it's up here, you know, just like, you know, you got the job on a USB, you load it up. Actually, I would put it into a folder on the computer somewhere so you guys can have it organized real nice. I will show you what these buttons up here do once we load something, because you can actually make duplicates of your part. You can move your part around. You can actually see some of your hatching lines if you want to really zoom in and look and see exactly how that laser is going to expose. Some of these buttons up here are to help you if a job paused on you, a job crashed on you. You look in there, there are ways to get it going again. Before you get it going again, you want to do a single exposure. That's what that stands for, single exposure. It's going to do the last layer height that you had running in there. It's going to fire the laser up and just run that laser again. What that basically is doing is putting heat back into your part, so when you hit the play button, you're not going from a cold part. So you got a couple ways to turn off the process light. You can do it there. You can do it here. And then another important number is so this is where your parameter, that's your adjust, this is your parameter page. Click that, this is where you actually have your parts over here. Once we load some parts over here, I'll show you the exposure. And then you can also change the recoding. The recoding is very important. There's no reason to use excess of powder if you don't need to use it. This is where you change that setting so you're not wasting powder. Or it could be that you have a big part in there and you had a small build in there last time, so you got you have a real low number in there, 75%. What that means is there's a chance you can short fill. You're not going to have enough powder covering your part, which means you're going to ruin that part, because now you're putting all this heat in on this side over here where no powder went. So you want to always look at the amount of powder dosage you're putting onto your part. This all comes into more of important once we actually start a build. I can start showing you.
So the dispenser always adjusts the powder level
Correct.
always, right?
It's adjusting it, but we can tell it by how much. We can either say 75%, 100%, 200%, because if you have a big part in there with a lot of surface, you're going to want a lot more powder coming out to make sure it covers your part. Larger the surface, the higher that dosing amount will be. Smaller areas, so it's smaller surface, you can have that number smaller. And there's an advantage that means you're not using as much powder. So your goal is, on the collector side, you want very little powder over there. There's no reason you need to have all that extra powder being dumped over there. Just kind of keep that in mind. And there's could be times where you have very little powder over here, but you don't feel like putting new powder in there. And if you calculate it just right, you should be able to do it.
So that powder over there technically.
You have to recycle, you have to sieve it again. You can reuse it, but you gotta sieve it. Just extra work.
Yeah.
So let's say you're in a hurry, you got this much powder, you know you have enough if you watch how much you're dosing it. It just saves you time. Why do extra work if you have to? I have a spreadsheet that kind of will help you with that. I'll leave that with you guys. So let's say you have 100 millimeters of powder over here, you plug that in there, and then you tell it how tall your part is, and it's going to tell you if you have enough powder and what the minimum charge amount is, what this number should be.
This also depends on resolution you're going with, right?
Yes. Yeah. It's going to tell you. Yeah. This is a laminator flow. So if you look, this goes on the newer machines. This has a spot that actually sits in the machine, so you don't forget it. The 280, they didn't think about that. This is very important. I have seen times where you start the build and you forget to put this in there. It's like, oh, dang. So then you got to stop. You got to pause the build, open the door, put it in there, and then you got to pump it all back down again. You got to wait. But it's always physically remember to look in there before you start it that it's in there. It sits, put it in here like that. Goes in there, and that helps the gas flow coming across. It's very important. Without this, you do have a potential for dangerous condensate in here, because this actually helps the flow and will suck in the condensate that goes into the filter. Without this, that condensate can actually sit here, collect on the sides of your machine. Now that we have this, let me bring this over. So we are going to change the nozzle. I didn't know you had it until this morning. We're just gonna put it in. And you know, you don't have to change this again. So this is the standard nozzle that came with the older machines. EOS found out there's a couple dead spots with the gas flow. One spot is like right around here. And the way the gas flows out towards these edges are not as good, so they went ahead and redesigned that. They 3D printed it. So this thing here is like $8,000. You guys have it. You can, take a look at it. You'll see it's been 3D printed. And this greatly improves the gas flow. It makes your material properties better. For everybody I've talked to that uses this, that have tested both this nozzle and that nozzle, they find the material is much better with the grid nozzle. So people just leave it in there all the time. They don't even bother to see what the book recommends. They just leave this nozzle in there all the time. And that's what we're going to do now.
So how often you change then with the,
What?
how often you change that?
No, you're just going to leave it in there. You're just going to leave that in there.
Whatever.
So if you look at the primer sheet I give you, they will actually tell, depending on which material you run, they will actually tell you we recommend using that nozzle or this nozzle. This is called the grid nozzle. We found from other people, just leave the grid nozzle in. Overall, you just get better mechanical properties with the grid nozzle. You're not affecting anything. You guys have it, might as well use it. Some people don't have this and they don't want to spend the $8,000 for it. You guys have it, let's use it. So where's your Allen wrenches? So that's why every day, before you come and turn this button on, check there, you can also check it over here. And later this week I'll show you how to do maintenance this. So I'll show you.
What are those should always be where you right guys?
That's the water.
Should always get that up.
Yeah, so you see the water in here. We actually added water last week. You got it. So they're right here too. The same marks are right here.
Okay.
So you got your max, your min. You wanna stay roughly right in the middle of that. These two marks. So we're good. Thank you. You guys got thick ones. Yeah.
You want regular ones?
No, these are fine. These are.
Yeah, that's kind of see, yes, that is.
So yeah, that's, and then I'll show you how to make this. Once a month, depending on how often you use it, you should clean out the powder inside the vacuum.
Each grid nozzle has different skills.
Yes. Yeah, you're gonna want to save the good one. Yeah.
We want to save it.
Save that one to go.
But I need tape. To put it.
It's like when you get a car, you take some apart, grade the parts.
Had something going in the back and you don't want it in there, I'll gas it off on you.
Are the same big plates that they use
Yeah.
same time.
Yeah, I think it is, yep.
So why did they make the blue plate so thick?
Well,
To remove the
There's
part.
two different thicknesses.
There are.
We ordered the thicker one.
I got you guys the thicker ones, you're gonna use this one more often. Plus it gives you a lot more, as you go there, remachine it, a lot more remachining on it. If you have a big bulky part, you want the thicker plate, less chance of it warping on you too. And it sounds like one of your builds, you're gonna have a big part, so.
And then you mentioned like it's good to have a good support structure. What kind of forces? I mean, is it a lot of forces that the parts are experiencing during the build?
There are internal stresses, yeah.
It's not the recorder, it's just maybe thermals.
It's the thermal stresses, yeah. Recorder's not too bad, it's the thermal stresses. Not too bad with MS1. Titanium is real bad. I think some of your Inconels, the stresses are pretty bad, but MS1 it's pretty good. The material you guys used to run 316 now, that's a really good material, not a whole lot of internal stresses. So I'm gonna go ahead and put this in the machine. Just as a demonstration, and then I'm going to have each one of you guys kind of, before I do that, I want to lift this up. Okay, I like to, make a good habit.
No?
Alcohol.
I like to wipe this off before I put the plate in there too. Now there's a couple ways of doing this. I'm going to just manhandle it, but I'll show you how you can use the truck. Yeah. I'm just going to manhandle it. Your machine is set up. You're going to put the screws on the sides, not like that. You could do it that way, but yours is set up to do it this way. And it looks like you got the correct length screws here, the longer screws.
And because we're only going 40 degrees Celsius, we don't have to wait.
Yes. Yep. Good rule of thumb. So what I do is I turn it. You'll see I screwed it down. Yeah, you don't have to do that. You can just go right in order. But what I like, you don't need to over tighten this. So you see right there, I'm touching. I'll go maybe an eighth of a turn. You see that? That's it. That's all you need. You're just basically holding the build plate so it doesn't move. You don't need to torque it. Like I'm touching. That's it.
You don't care that it's not perfectly flush on the edges, right?
No, because there's clearance. That's it. What will happen if you have a big part on here, that part is going to have some stresses, so it's going to be trying to curl the build plate.
Yeah.
So when you go to loosen that, it may be a little tight on you. That's where it might get a little, but that's it. The next guy wants to come in and loosen them, feel how tight I had them, and then go ahead and just kind of
Loosen and tight.
yeah, loosen and tighten them. Anyone wants to go over it?
Set up with her piece of print.
Yeah, I think we ordered. I had you order 10 or 5 new ones at the minimum. So now I'm going to show you how to use this guy.
Okay.
So there are chances where when there's nothing on the plate. It's a little heavy, but you can manhandle it, no problem. But let's say you have a big part on there. It's starting to get a little heavy. Come in the middle. Unfortunately, you want to be in between there. just above, lock those wheels. Slide it on like that. So if you notice, this is a little bit above this.
Yeah.
So you can, and it's the same thing, you would put it on there. If you didn't have, if you had somebody that didn't want to lift that, you know, they were, didn't want the risk. It's the same thing, you get it up here, you just bring it up just barely above this. And then you can slide it. Slide it on there.
Are we doing this in the blue suit as well, since basically you're gonna have powders?
You would. I'm not.
Okay.
I feel comfortable, I know what this material does. MS1 is a heavier material.
Yeah.
I'm comfortable, as long as I know I'm not stirring that powder up.
Right.
I feel safe. Now I will have a mask on. Once you get on there, just pull it out of the way. I like to bring this down on my face view. That's it. For our demonstrating purposes though, we'll just do everything, because I think we can all lift that.
That's not an issue because I guess the code will.
Yeah, so the rule of thumb is as long as the plat is flat to 1 layer thickness, you're okay. So we're running in 40 micron layers. So as long as this plate is within 40 microns being flat, there's no reason why we can't get it to that. And sometimes, yeah, a plate will be bold.
Yeah.
As long as it's within 40 microns, you're okay.
Come on, Pablo. Come on, Pablo. For free. For science.
I know, but if you wanna for you at home, you have to experiment.
Right.
Guess they didn't just throw it in the service.
No, we'll have to take a look at that.
Yeah.
Is there a lot wrong with this system?
No, it wasn't
Yeah,
bad.
it's just
Not at all. So then you can also move this, so while you're working in it, you can actually see what's going on. So all I'm doing is lowering it. So if somebody wants to hand me the vacuum, there's a little bit of powder that came up there. I want to vacuum off. Leveling this plate. So basically we want to get the top of this plate somewhat level to this black frame. So what we teach everybody, what we do is we'll put an Allen wrench up there. And I will bring that up until I think it's fairly flat and level. You guys remember this from previous training, whoever did it? So to me, if you look, I think that's fairly level. It doesn't have to be perfect at this point. You just need to be close. I'll take that out of there. Now I'll use the dial indicator. Here's your feeler gauge too. We'll leave that out. So what I like about the 290 is you can actually move that recorder blade without having to move it by hand like you would in a machine like this.
On the previous training, they just started kind of showing us how to manhandle it.
It's tough, I think, to manhandle that.
It's not easy to get it started, yeah. Especially when it's all the way at home.
Yeah, it's not like a 290 where you can actually move it pretty easy. Oops, I went too far. remember who did the previous training?
I don't remember.
Was it Vince?
I think so.
I think it was Vince.
No, first was Mike.
Well, he did the
Where
the
we
training.
started.
but the training was
Wait.
Vince, I think, wasn't it? Vince Mauricio?
Yeah, but first Mike, do you
No,
remember?
but the training, just the trainer.
Vince.
Yeah.
Okay, so now I'm going to let me adjust your dial indicator here. It needs to come down. See, it's not even touching the plate.
Right.
Okay, so now I know I'm touching the plate. So by getting this fairly level, you're allowing the indicator to touch.
Zero.
Yeah, so I like the zero in the back, and the reason for that is let me explain what's going on here. I'm pretty sure whoever you trained you last should have explained this. So I always start in the back left because this is a stationary point. It's not going to move. That corner is not going to move. There's a motor under, an adjustment under this corner then. Yep, so this is basically a kinematic mount. So it will move here. And then when you move it to the right side, it only moves right there. So when I move to just here, your pivot pointer is right here in the center. So if you notice I have my indicator set to 0 back there. So now I'm going to move it forward. See what it reads. And it's not bad. It moved two lines, which is 20 microns. I like to be within plus or minus 10 microns. So what I'm going to do is I'm going to move this down. As you can see, I'm getting closer to my 0. There's 0. I'm going to slide it, make sure I'm roughly the same. 0. 0. I like it. So now I'm going to move it to the middle. Because I'm going to come over here and I'm going to see where I am from there to here. So now I need to, so it looks like to me the plate's a little bit like this. So I'm going to go ahead and 0 this dial. So I'm 0. I'm going to run it over to this side. Right there. And if you look at my dial, I'm 1, 2, 3 lines low. So, or high. I always get confused which direction, so I'm going to move this down. Nope, wrong way, so now I'm going to come back up. So it goes to 0. As you can see, I'm at 0. Run this back over. If you notice my indicator, I'm still at 0, so I'm pretty good. So now I'm going to run it back to the back. Re-0 the back. Run it to the front. See if anything changed in the front. You know, it's pretty close to 0 again. So right now I think my plate is fairly level. So I'm done with the indicator. So I'm going to bring the, I need to bring the bill plate up, so I need to move the recorder either to the left or the right. I'm over here to the left, I'll just finish to the left. So now this is an important number to remember. So now that I have that level and I'm fairly level to the black frame, I'm going to bring this up 3.5 millimeters. Important number, remember that number. 8.5.
That period might not work. I have to use the one on this.
Oh, that might be a comma?
Yeah, I mean.
Oh yeah, I see it there, it's a comma.
Yeah,
It's a German.
it was very annoying.
So So there's my 3.5 millimeters, I just brought it up. What that did is now, I'm gonna finish everything with the feeler gauge, because now I need to get my 40 micron layer. Because if you remember, I need 40 microns. So now this is how I find my 40 microns. So,
what are the four numbers that we have to remember? 40 in the collector, right? Millimeters.
40 millimeters, yep.
In the collector.
Yep.
35 in the billion platform.
3.5, yes.
At 3.5. So
Yep.
3.5.
And there'll be a couple more to remember here. So now, normally I like to manually move this to see how it is, but on a 280 it's really hard to do. So there is a slight chance I may hit, but I don't think I'm going to hit.
We're replacing that plate anyway, right?
Yeah, but
It's not good, but.
no, we should be fine. Now, if you wanted to, we can slow this down.
Does it stop when it hits?
It will, but it'll still go clunk. You'll hear it, you know. So I slowed it way down to 50. So I can tell I am not going to hit.
Must be a nightmare every time.
And I can see there's a little gap, so I'm good. Here's where I kind of figure out where my gap is. This is going to change each time. Because all you're doing is you're eyeballing it that very first step. And for each person it could be different. You're just trying to get a rough estimate. So I always like to start with a 0.5 millimeter. Where is the 0.5 millimeter?
We mark one.
0.55. 0.45. Let's see the half. Either way, we'll go with 0.55. Wonder if this is it here. Here it is, right at the bottom, 0.5. So with a feeler gauge, those of you who are not used to a feeler gauge, you don't want to be feeling like that. You want it flat on that build plate like this, and then going
Much
under.
gap, right?
So I can feel it going underneath. I can see it there. And like I said, you don't want to be like this. You want to be flat. And I can see, you guys can see it. I'm going under, and I can feel it quite a bit. So I'm going to go with a 0.75. And I'm hitting, so I'm not going under. So 0.75, I'm going to go with 0.6. Same thing, you know, make sure you're flat out here. 0.6 is going under. So I'll go
0.7.
0.65. So it doesn't fit. So that tells me my gap is 0.6. So now I'm going to double check and make sure my gap is 0.6 over here too. I'll speed this up since I know I'm not going to hit. And I really don't care what the plate does out here on the ends. I just really care about the middle because you can't adjust the ends. 0.65 doesn't go under. And hopefully 0.6 does go under, and we're good. 0.6 goes under. So that tells me my gap is 0.6 millimeters from the bottom here to the top of my blade is 0.6. I said I'm doing 40 micron layer height, so I would subtract 0.04 from 0.6, so my height I would bring this up is 0.56 millimeters. So in here I'm not going to do it because we're not actually setting it up. So right here, I would actually put in
0.56.
0.56.
And you could do that with the recorder already.
No, you can't do it with this. I'm just showing, this has to be over either all the way to the right or all the way to the left for the build platform to move up. It's a safety thing. If if you try to do it, the machine would, I think, a little error saying recorder needs to.
It's all grayed out as well.
Yep.
105 minus.
0.04. 40 micron.
105 minus.
Minus whatever your gap is, which we said was 0.6.
0.65.
0.6.
0.6.
And the reason it's 0.04 is that's our layer thickness.
Right.
So if you were doing the performance and doing 20 microns, you'd subtract 20 from 0.6.
Yeah.
So then it would be 0.58.
Yeah.
So that all makes sense for everybody?
Yeah.
That was a quick explanation of that. I'm not actually doing it because we have the wrong blade in there. So now I'm going to pull this blade out. And then after lunch, we're going to take turns doing this. I'm going to come over here and mess this all up, and you guys are going to come over and re-level it.
All right.
For that, I want to do the blade. So the blade's all the way to the right, but I can't work on it. I like to bring it off of the, off and to the right. I like to bring it about there, just so you can work on it. So you'll notice we don't need the torque wrench to take the blade out, but we will need the torque wrench to put the blade back in because there's a proper torque setting for the screws. The other wrench doesn't matter, and you're going to feel these should be fairly tight. And I think they're actually too tight. I always come off of what EOS recommends. EOS recommends 14 Newton meters. We've been starting to tell everybody to do 11 Newton meters. Just 14's way too tight. I mean, you can hear it. That's just too tight. So there's 7 screws. You like to catch them if you can, if they fall down into the powder. That's kind of no big deal. Just make sure you clean off the powder from the screws before you put the screws back in there. You'll see this is a tedious part. Maybe we'll have one person demo this, but if everybody wants to do this, they can, we'll do it. But I think once you see how it's done and you just remember it or you can document it, I don't think there's a reason everybody needs to do this part.
You probably said it before, but when do you recommend changing this?
If you feel that there's damage to the blade, you would change it. Or if you change the materials and the material requires a different blade. For example, 316, what was previous in here, high-speed steel was what was recommended. Raging steel, the ceramic blade is what's recommended. If you run like 17.4 pH, ceramic blade is recommended for that material. So this is the cover. This is the high-speed steel blade. Somebody wants to give me a wipe with a little alcohol on it, or we'll just wipe this off. Put it away.
Which was the position? This way?
Is there a little?
Reversible.
Is there,
Huh?
It's reversible.
Yeah, but this part. Have to be like this. Look,
Yeah.
huh? Look, this angle facing this way.
Yeah, that angle faces down.
Like
Yeah.
this. Okay.
That's the cover. That's an easy one.
Yeah. I know, but this one has to be same orientation, right?
Yeah, so it doesn't matter which ceramic blade or this blade, you're gonna notice, if you notice there's an angle on it. Just think about it as you wanna plow into the powder. So you're going from right to left, so remember you wanna plow into the powder, not push the powder.
Yeah.
You wanna plow it. So remember that, it's always like that. And then you got two sides to a blade. And then you just rotate it and you got two sides.
So it's just meant to have.
Okay.
Yes. Yep, meant to have two, you've got two good uses. High-speed steel blade, very sharp, that's why I recommend using the back of your fingernail. And if you do feel a nick with the high-speed steel blade, luckily you can, if you have a nice little stone, you can actually polish them out of there. Ceramic blade, once it chips, there's no fixing it. So depending on how big the chip is, depends on how you have to replace it. So I'll trade with you.
Yeah, this thing, I guess. EOS seems very big on chocolate packing peanuts.
I'm just glad you guys got all this stuff. Yeah, Dr. Shu's like, just order it. I gave him a list and he's like, let's just get it.
Yeah.
Yeah.
Well, there's budget for it, so that's I think what made it easy.
So again, you know, not that way, you want it that way. And if you guys do accidentally drop this, if you drop it on here, it probably won't do any damage, but if you were to accidentally drop it on the concrete, it probably would shatter. You know, just remember that, it's ceramic.
That's what your bathroom sink right there.
Yes. You know, I just took a visual look at that, and you can tell this is not as sharp. I can run my fingernail across the edge. So what's something I do want you guys to look at is that when you look in there, you're going to see little pads on all the way to the back and to the front. That's all that blade is sitting on, are those two pads. So you want to make sure those are clean. Poke your head in there. See the two ledges? That's all that blade is sitting on.
So that determines its entire
Correct.
position.
Okay.
I can see it from here.
So, just trying to wait in there. So I just like to keep everything clean. Try to get that going in there the right direction.
You need two people, right?
Now, one
Oh, really?
person, it's tough to get two people in there. So I'll usually put the cover in there. Start with the center screw, just kind of so it holds it. Get some more Allen wrenches. I like the Allen, you know, with the ball on the end of it. Makes it a lot easier. At this point, all I'm doing is I'm going to put these screws in there until I just feel it hit the bottom. I mean, that's all I'm doing.
The ceramic's harder.
Yeah, so there's a couple reasons why you want ceramic. So if you were to use the high-speed steel on the raging steel, there's a chance that the high-speed steel will magnetize, and then your powder is not going to flow real nice. It's going to follow your blade. So that's really the only reason they're really going with the ceramic blade on your steel powders.
Oh, right, because it's the only magnetic.
Yes,
steel
yeah.
powder.
And if you notice, like on your aluminum, titanium, stainlesses, it's always the high-speed steel blade because there's not a chance for that magnetism being an issue.
I just assumed because it was I know the raging steel is significantly stronger than the 316 as printed, right?
Yeah, mechanically, yes.
So you clean when you change the powder, right, for different materials. That's the only time.
Yeah.
Why don't you clean it?
To what? To change the grain of
Yeah.
the grain of the material that you are going
Or if you feel that you
Yeah.
feel like there's some big damage on it, you're gonna have to replace
Replace that.
it too.
And it looks like we just got the one for now, so I guess we have to make sure we get a second one for back up relatively soon.
For
The ceramic lid.
you should have gotten two. You should
I
get
think
two.
we have it already. Yeah, we
Okay.
have it. With the
I make
first
su-
part
yeah, I
of the
always, and I'm
Yeah.
pretty
They,
sure I put
they,
two
they
on there.
include it, yeah.
Okay.
I like,
This is one of the boxes.
okay.
So you break one, make sure you order. Call
Right. Same
us
day.
up, and we can
Couple
get
of
you.
them.
We can get you some more. Then yeah.
So we only have
can
one
check later
a
on.
high speed one.
No, I think I saw an extra high speed in there, so you should have two high speed in there too. The brush blade, I saw at least two sets in there.
Yeah, so I think we have.
Depending on time, I definitely want to show you how to use the brush blade, and there's a demo part that I'd love to print with that brush blade.
Yeah, I think we really would like to do that because the next.
Because it sounds like you're going to want to use the brush blade.
Yeah. Yeah, I have to get a lattice structure, a bunch of lattice structures
Yeah,
printed soon. So
You basically need a brush blade to print lattice structures, because it's, especially if it's real delicate.
yeah. And we're trying to keep the wall thickness up enough because I know that tends to be a failure point for these, but.
So basically, I come in, my screws, I'm going to back it all off a little bit, because what I want to do is, I want that ceramic blade to float.
So unfortunately, you have a situation where you have your high-speed blade is broken, but you do have a ceramic, and you use it for the stainless.
You could. So that's what I want to hear. I want to hear it floating like that. So by it floating, I know it's.
You're secretly recording this, man.
What was that?
Secretly recording this.
Yeah.
Paparazzi. It's like a,
Yeah.
So, if you remember from safety video, you don't want to swirl the powder, so we're gonna slowly get this powder over here. You don't want to just pour it, because then you're gonna. I always find that it's important. Make sure you have at this point. Make sure we have the lens cleaning on, which it was not on, so now it's on. You see it right here?
Yeah.
In order for that to be on, you have to have the compressed air on. It was not on, so I just hit that, Now we have the lens cleaning on. So if we do get a little bit of powder coming up, it's not going to stick to our lens.
that'll be helpful.
So what I like to do before I continue, got a scoop here.
We use this.
Oh, like,
So that build plate is pretty sturdy to not move even,
Yeah,
even
oh
with that
yeah.
weight.
This one on my corner.
Could you reiterate one more time? Sorry, just why you cleaned it.
I didn't want any contaminants in the machine,
Okay,
because I'm putting it on the build plate. Keep in mind, I can put it on this build plate because it's only 40C. Some materials, it's going to go hotter. Be careful.
Right.
You won't have this luxury. Like aluminum goes to 200C, you're going to melt that. So remember that. And I think stainless steel, what you had in there before goes up to 85C. It's starting to get a little warm. It'd still probably be okay.
it's very close to boiled water, right?
Yeah. Well, at 200C, you're past boiling.
So the inert gas emission is too low. Right?
Yeah, we're okay. The inert gas, we're not filling it with inert, so we're all right. Now, there is a desiccant container in there. Just hang on to it. If it falls in there, just pick it up and put it back in the container. So you can either do some scooping. This is how you would do this carefully.
Very fine.
You see how I'm putting it in there? And I'm doing it this way because you don't want to, like I said, make big plumes of smoke, stir it, or powder, stir it. And I think at this point I'm actually going to take the desiccant out. So it's out of my way. Don't take it out of the machine because there's, you know, it's still got powder all over it, so I kind of set it off to the side like that. So now I'm getting close to the end. Now I'll finish pouring, but very, carefully. Take the desiccant, put it back in here. And at this point too, it's also good hygiene. If you see powder on there, you're going to want to wipe it off. And a little alcohol, you can wipe it off.
So do you normally put the whole thing, or is it just based on how much you need? Just a rule of thumb, or no?
Once you open it, just pour the whole thing in there. Because it's no sense in only pouring what you need, because you've already opened this.
Yeah.
It's got oxygen going in there now, you might as well just pour it all in there. And at this point too, you want to save these containers. Don't throw them out. Because if you ever switch materials, you need a container to put the material back in. And the other thing that's good about one of these containers is, so I actually called one of my colleagues and asked him about removing the powder from that area there. He said, mark one of these containers as waste. And he recommends putting that in here. Once this fills up, you would, he says you can just throw it in the dumpster. But if you got to call hazmat for your filters anyways, just have them pick this up at the same time.
Oh,
Yeah, that's how I would do it. Yep. Alright, it's going to be,
Side mode.
yeah, just going to raise that up.
How do you pour this?
Tandem.
Thank you. Thank you.
So I wonder how they deal with the fact that there's this gap between the platform and the walls, and obviously powder gets through it.
There's like a gasket.
Yeah, there's a gasket to stop all that. Yep.
This is it.
It's heavy, huh? It's heavy.
Exceedingly heavy. Look how little there is.
The powder.
So I raised it up somewhat close. Nothing important. And then I'm gonna take this and go slow. You don't want to, like I said, you don't want to stir the powder. You can see how easy my spatula is falling in there. It's going to start getting denser and denser as I compact that. Very important to do this because you're getting all those air gaps out of there. Rotate it around, different directions. So now you can feel I'm not hitting the bottom anymore because it's getting denser and denser. There's a spot. Everybody can kind of go in there and just do a little bit of that and feel that. So that's packed pretty good. I know that there's no air. So now we're going to bring this dispenser area up, and then I'm going to somewhat get that all level. If you guys look in there, it's kind of all over the place, so I'm going to take the ruler. Kind of run it over, make sure I get it, so I can see I need to come up a little bit more. So here's where I would get a cloth with a little bit of alcohol on it, getting ready to wipe this off.
How would you do this otherwise if not for Vince's trick?
Just eyeball it.
You just bring it up and then use the recorder?
Yeah, that's how I used to do it. But
Okay.
this is a little bit quicker way of doing it, saves you some powder.
Yeah.
You can see I still got a little too much powder here. Not a complete waste though, because I'll leave it up here in the beginning, and we're going to I'll fill this gap right here with it. See how it's going down in there?
Yeah.
So now, this is why always have a little cloth with some alcohol on it so we can wipe this off. You don't want to just set this down all dirty. Try to get your fingers here. Just a good habit.
Also the spatula.
Okay, so now pretty confident. We're going to go ahead and level this. So we didn't mess with it. We brought it up to 0.71 for when Pablo said it. Bring that over. Here's where I'm just going to eyeball it. I'm going to bring that powder up to the bottom of that blade. Right there. And now I'm going to still need to go up a little more. You can see I didn't quite get it. So you don't have to do this step, but I always recommend doing this step. It's just an extra step to remember. So if you do this step, you just have to remember it. So I like to put a number in there. I put 0.2 in there. I like to lower the build
Did it twice?
and lower the, just one time.
It sounded.
It sounds like it's doing it twice because it automatically brings it down past and then comes back up to get any backlash out. And then I do 0.2 on the dispenser side. And the reason I do that is so when the blade comes across, it's not rubbing anything. So let's say I hit
Okay.
powder on there,
Okay,
it would
okay.
rub.
Again.
So before you forget, bring it up, bring it up. So now we know where we're at. I need to bring this up a couple. I'm gonna bring it up like, and I'm gonna coat.
Not there yet.
Now I need to bring it up quite a bit more. So now I'm gonna, my numbers are in there, bring it down, bring it over. Before I forget, up, up. But I'm gonna do a rough. That should kind of do it. Almost. You can see it's got, I got some powder.
Yeah, you wanna get the,
Okay.
so you see what the coating looks like.
What was that?
Yeah, because you wanna see what the coating looks like.
Okay, okay.
Yeah, the first layer is important.
He said it's the most important.
Up.
That's a lot.
And there we go. If you look to me, we'll do that one more time so we get an even cover. If you guys look, it didn't quite cover the plate good. But I'm looking at this and it looks a little thick to me. You want to see a little bit more of the plate coming through. So I'm going to go ahead and lower so I'm not rubbing. And at this point, I'm going to bring it up.
One side.
Bring it up so it's where I know it's where I'm at. And at this point, I'll put my head in here. You notice I don't have a whole lot of powder over here, but I will take it. I'll take some of this powder, and I don't have much, and I'll fill some of these holes up with it. Sometimes you have a little more powder, but I don't have a whole lot this time. And we'll try that again. Still got a little spot over here that didn't fill. But I can tell it's a touch thick. So this time what I'm going to do is I'm going to lower, bring it over.
You got too much height between the recorder and the build form?
Bring it up. Yep. So now I'm going to raise it. I'm going to raise it 20 microns. Or so 0.02. Oops.
Wrong point, the number.
0.02. You heard it move? Just barely move.
That's the business.
Much better. You see how now you can see the build plate? You see
Yeah,
some of that
color.
shiny coming through? I like that. That looks good. Go ahead and everybody take a look. You want to see some shiny build plate come through like that. That means you got a nice first layer. If you don't see any build plate coming through, that means that first layer is going to be a little too thick. Okay. Okay, nice. Everybody like that?
Yeah.
So this is the size of
Something-
one layer.
Yes. So now we're basically ready to run. But before I start pumping the machine down, what's something that we need to do? This guy, right? The laminate oxidative flow, always look to do this, because if you pump it down and then you realize you forgot this, well, guess what? You open that up, now you have to wait for it to pump down again. So always look for this before you pump. So now we can close that out. We're going to start initiating everything. We're going to turn off the lens cleaning. Oh, that's a good
Clean the
point.
lens,
We're going
yeah.
to clean the lens.
Lens cleaning, okay.
So we turn the lens cleaning off. I like to make sure my hands are clean, so I'll actually take my gloves off at this point.
So you turn the lens cleaning off to clean it.
Yes, yeah, you don't want the air on now.
Oh, because it was on before.
Yes, it was on to keep the powder from going up there, but now you don't want to hit the center where it's going to be touching the lens. So you pull it out, put it upside down, and you're going to make a parachute with it. Being very careful not to touch the center. So then you put your drop of alcohol on there, and you're going to put it up onto the lens. Not a whole lot of pressure, just a little bit of pressure. And you're going to start from the center, and you're going to swirl yourself out. And just take it right off. And again, very light pressure, just enough so the cloth is touching the lens. Then you pull it out, and like I said, it's the parachute. You always want to keep that center.
So your finger is not like putting pressure, just the pressure of the paper.
Just the pressure of the paper, that's all you're looking for. And if you look, I'm very careful, I'd never touch the center. That's good enough. If you want to just get a drop. 2 drops on there is fine if that's, but you never want to saturate it. Good. You're going to watch, I go up in the center, just a little bit of pressure, center to out. I look at the cloth, I don't see any dirt on there, I won't wipe it again. Now if I saw some dirt on there, I'd wipe it a second time with a new one. Never reuse these.
So just to reiterate, when you did it, your finger was actually putting pressure on the lens, right?
I mean, I'm pushing it up there enough where
Through the paper.
the paper is putting the pressure on there. I'm not pushing it up there where my finger is.
Oh, it's just the paper.
Just the paper. Just enough pressure that you're pushing up there that the paper's touching.
So it's that delicate.
Yeah. Well, it's not that it's that delicate. There's a coating on that lens.
Yeah.
You just don't want to scratch it and wear it off.
Right.
Because then you're talking, I think it's $10,000 or $14,000 to replace that. And here's where you can turn off the light. Your battery's dead on that flashlight, but then just pull out yourself. I'll go check the shine a light up there, just make sure it looks clean. Well, lens looks really good. If you guys want to take a look, go ahead. You know, pull the phone out. Make sure it wiggles. There. Yep, we're good. Shut that. I know for a fact it's going to ask us to home it, so I might as well just home it first. Now we can close that. We can start pumping everything down. We can pre-flood. And at this point, we are going to. You guys can see. Might have to have John look up where's your old job from?
Oh, so you, yeah, it's in there, so the heat exchanger.
Heat exchanger?
I don't know, maybe not.
So we want to find that calibration job, your old calibration job.
Yeah, that might be in the maintenance folder, but I'm not really sure.
Is it on desktop?
I don't know where the
Folders?
calibration one is, honestly.
I think right here.
Now fine tune.
It says 316 now, it doesn't matter. So if you notice, this is the job that the technician put in there. It's saying, hey, it cannot be loaded as the machine parameters. We changed it to MS1. It says, do you want to convert this job and load again? Say yes. So what it's going to do is it's going to reload, and it converted that job to MS1 with the correct layer thickness. Oh, yours actually put
EOS.
it actually put powder. I mean, it put support down. So we're going to actually skip that. We don't need the support material. See that over there? So if you look, the support material starts at 2.15 millimeters. So I'm going to lower that whole build down 2.15 millimeters to skip that part. Normally, we don't ever use the support like that on the
Calibration.
We go just like here. That's what the technician did here. You notice? Straight to the part. Why they gave you this one, I don't know. I have another file I'll give you guys so you don't have to do this, but it's a good learning experience. You just open up your parameter page. So there's our part. You see it's got an OM in there. That means that is your support, and then your P is your part. So if you look here, it's saying no exposure.
It's okay.
That's actually external support, but I'm going to just say no exposure. The part should actually say direct part. I hit that, I'm going to say apply. I want it to remember that. Because if he left it at no exposure, the laser wouldn't even turn on. It just go do its layer and continually think, no exposure. I'm going to leave that at no exposure because we don't care about the support. But I am going to lower 2.15 millimeters. So I highlight both again, so it's the group. I'm moving the group. And what I'm doing, I'm moving it minus 2.15 millimeters. And I put the negative in there, and now I'm going to say move. It's giving me a warning. I know that, I don't care.
I mean, because essentially it's going to be building the structure below the platform. Imagine like without exposure.
Yes. So I'm going to say okay. Okay. And now we can take a look.
That's what.
Now my parameters said speed was 40 microns, but I'm looking here. It looks like it's actually doing it in 50 microns. See that?
Oh yeah.
So my parameter sheet must be it's outdated. Doesn't have the latest in there. So I was kind of wondering why you had three choices. But you can see. It's going to go to a height of 7.45 millimeters. You can see our process chamber, we're down to 5.8% oxygen in there, 5.6. Once that hits 0.12, we can start running.
Yeah. So the calibration, is it like a timely thing you do, or you do it all the time, or just once?
Like I said, just when you change materials.
Change material, okay.
Or if you feel like something's not right.
Okay.
Over time, maybe after a year from now, the power setting changes ever so slightly. And you're measuring your parts, and it's like, why are my parts not quite what they should be? Run a calibration job.
And then
Because that's what you do. Tomorrow when we break it out, I'll show you. You take the measurements off of it,
Yeah.
and it tells you the beam offset, and it's also going to give you the correct scaling on the part. And the scaling is very important if you want dimensional accuracy. It doesn't affect your density or the material properties, but it affects your geometry.
So So do you just hold on to those plates, or do you eventually just
No,
machine
machine
them
them
when
all.
you're done?
Oh,
It's
yeah.
just more of a pain to get that off.
Correct, it's harder to remove than, yep. But if you got your machine set up to clean the plates, clean them all off. Yeah, you don't need to keep that.
I assume, but yeah, there's not much in the city here.
Yep, no, machine it off. You see we're down to
To wait.
4.5. Here, I'm just gonna double check our group. Direct part. No exposure.
So, okay, but what is that
One day
indicating
before
now? When
printing,
you
you
move
have to,
fabric
like,
down?
review
This
all the
is
details.
each layer.
Oh, each layer, okay.
Yep. So you can see for the first how many layers, it's this, you're building the same thing, nothing's changing. And then as we get taller and taller, it's got these little, oh, you're building this part. That's why it's doing that. I'm gonna get you a different part.
Okay.
I just noticed it right now. This is a really old calibration build. We don't really use this one anymore. So I have it on the D drive or this one here. I have it under fine tuning. And we're going to do this one. This is the latest. Air unpacking, fine tune, while on job. Okay. Didn't like that one, so we're going to run load the other one.
No, we just started.
Okay, so this is the new one we're running.
We have done the same that we printed.
Are you gonna be able to put a copy of that on the
Yeah,
computer?
yeah. Plus I'll leave you a copy.
Yeah, okay, great. So we'll have
But that goes
So-
with what we printed. Last time.
similar.
This one.
It's
Yeah.
similar,
It's the same.
Yeah, what was in the, yeah, it's very
That
similar,
one.
yeah. What's in the
I'll
machine, that I found the old one, I didn't find the new one. And if you really wanted to get fancy, you know, you could put names and serial numbers, but we're just gonna print it. So what I wanna make sure is we have an exposure. So here's our, we'll expose everything so you can see the little laser, we don't wanna do the build plate. Down here, direct part. Apply. So now we can come in here and individually make sure everything says direct part to it. That's good. You can see the different, and we'll 10 millimeters, we'll let that run and we'll see what it does.
Do you always run the calibration in a certain setting, like instead of speed or performance?
It doesn't matter, so we're running at speed. So here's where it matters. Let's say you decide you want performance, you would have to do another calibration job. Because you are changing the way the power goes into the laser. The mount pool is going to be a little bit different between each one. And when you run the calibration job, because you're basically taking and measuring those, and you'll be able to tell what the mount pool is doing and make adjustments from there.
Okay. Is it possible just to run the job estimation process?
Yeah, we can do that.
Just kind of curious.
You can just hit the little thing, start up here, little clock. I think it's like a 2-hour build.
Yeah.
Looks like on a 280 it's actually quicker. It looks like an hour and a half.
Cool.
Once you hit 20% over here, you're going to notice the time really doesn't change, so we never really, once it hits 20%, just stop. Looks like it's an hour and a half build. We're at 0.28, so we're going to start this. So here's our build. We started flooding, so it's not going to actually start until it hits a certain number, but we're going to hit play up here. Laser says it's ready. And it's going to wait till it reaches conditions, which is 0.12. I can hear the airflow. I'm double checking it here. So we got our air, we have our gas, and it's flooding our two chambers. So everything's working. This is a little bit lower than it should be, but I think we came in, we heard an alarm button.
Yeah.
But we still have air pressure. As long as that doesn't fall below 5, I'm happy. I know Mike likes to keep that up about 6. Yep. So we're good.
So it's going down.
That's
Whatever the inert gas is gonna be up.
yeah.
So this guy's going down.
So it's hopefully that doesn't go down too much. And this one here, as long as it's around there, we're okay. Once it pumps down into the 1.2, it uses very little to keep it full of nitrogen. Because basically you need the compressed air to go into the nitrogen generator that's pulling the nitrogen out of the compressed air.
So it's probably hovering around a point.
So you can see the numbers changing, so we'll just let that pump down. And what happens is when it hits a certain level, you'll hear the filter turn on and you'll hear a little turbine kick in, which is helping to circulate the air.
The simulation system.
Yep.
Does that have a feature to send you a text when it started or when it's done?
What's it?
Like a text message, hey, it's done or it's started?
Yeah. It would be nice if we did that. Here, this is your focus, and you can see it's on 0. That's what I wanted to. So that's where you would adjust that. And people would love to come in there, especially the guys at the universities that really like to experiment, play around. They would mess with that focus. But you definitely want to make sure our parameters.
Zero their focus.
Yeah, parameter says 0, it's at 0, so we're good. You know, until you get used to it, use the default.
So that's the money maker right there.
Yeah, this is your fiber optic, this is your laser, this is your collimator, so it's stranding out your beam.
Yeah.
This is your expander, making your beam bigger, and then you got your mirrors over here.
Those mirrors
Yeah.
must be incredible how they're moving.
Oh, yeah. Those mirrors are the key to everything. They're my default scenes. Whenever you see a B, that means it's the build processor. For example, I can come up here and I can add another scene, and I will open up I'll just open up a 280 scene without the build processor, and you can see that it doesn't say the B on it. And if you also look, it doesn't show me my bolt holes on the platform. Where on the M290, it's the same as the 280. It's showing you, hey, don't throw a part on there. But it really doesn't matter because you're going to rearrange it. I showed you how you can rearrange it once you get on PSW. You go in there, you can move it around, do whatever you want with it. So it doesn't really matter at this point. It's when you bring it into the PSW software that you can rearrange it, and it's showing you where the bolt holes are. For now, I'm going to just do a simple block. You can do that right here in Magix if you want, or just do a 100 by 100. The first thing I like to do is something that, you know, if you read through the steps, it was kind of like the 4th step, but I actually like to do it as my first step, which is to fix the STL. Most systems now, it's very hard to really mess up your model. Everybody knows how to model. The CAD systems are all pretty good now, but there is a chance that whoever drew it didn't draw it quite correctly, and when you convert it to an STL, it doesn't come over correct. It could either have multiple shells, it could be missing a triangle, it could have overlaps, it could have inverted. So those are all things you want to look at. So you go to the Fix tab. If you notice up here at the top, you got your tools, you got your Fix tab. You can go to the Fix Wizard. When you go to the Fix Wizard, you see it brings this little thing up here.
Go ahead in there, these overlapping and intersecting triangles are not super important. On a simple part like this, I'll leave it checked, but let's say you have a very complicated geometry, lattice structure for example. I would uncheck those bottom two, just to see what it does. I guarantee you with lattice structure, you're gonna have some overlapping intersecting triangles. The part will still build correctly. You come over here, you say update. Everything comes back with green checks. We're good to go. Shells. Sometimes there are times where you're going to want to see two shells on there. If you have mating parts with a hinge, or it's got a live, you want it to have a movement built into your two parts or multiple parts. That's where you would ignore your shells. But if you ever see two shells, three shells, and you know you're only building one part, you got something wrong with your model. Let me just show you what happens when I will come in here and I'm going to delete a triangle. Okay, we'll delete it. So whenever you see red, that means you're seeing inside your part. You never want to see red. So right now we are seeing inside the box, our block. And now if I go in here and use the fix wizard and say update, well now it's detecting 3 bad edges, a bad contour, and it's detecting a hole. Alright, so there's multiple ways of fixing this. You can either fix it manually or you can, let's just see how it says we follow the advice. Follow the advice, you say automatic fixing, hit the diagnostics, say update again, boom, fixed everything. The only thing I don't recommend ever doing is this auto fix. There's times where you don't want it to fix something. So that's why I always like using the fix wizard and just manually going through it. Or you can come in and fix it yourself. Let's say you see a hole, you can come over here and go to the hole fix. And it's going to fix all holes. And it's not looking for anything else but holes. So then we come over here to fix wizard. Let's just see what it did. It all looks good. Again, this box is very simple. When we do other sample parts tomorrow, we'll look at this in more detail. Clear the green is F8. Second thing I'd like to do after I fix it is position the part. We can go to my default. My default is set up. Well, it's at 10. I guess by default is not set up. A good number. I know what it is. A good number is 4 millimeters off of the part. Some people say 5, some say 4. I like 4. Why have it build that extra 1 millimeter? Because all that's doing is extra time. Because that's how many layers in 1 millimeter. It's quite a bit. Depending, I like 4. 4 gives you plenty of room to get a chisel under there, or if you have to use a saw blade, it gives you plenty of room for a saw, but you're not going to affect your part. One thing I do like to do, look at, once you set it up, it should remember each time. So if you look at my X, Y, Z coordinate, if I come over here and hit, like Z is the important one, so I want Z always at the minimum. If you watch what happens when I hit middle, coordinate goes up, or if I hit max, it goes to the top. Well, if I have it in the middle, for example, and I say 4 millimeters, I have no idea where my bottom is to the plane. But if I say minimum, I know that my Z is measuring off the bottom of the part. If I say 4 millimeters, it's 4 millimeters.
It's changed on the ABAP too, right?
Yes.
Yeah.
And we'll double check your settings
Right.
Once you use it, Magix will remember it. So at that point I say, okay, so I'm 4 millimeters, I'm on my build plate. I don't care exactly where it is on the build plate as long as it's on there. And so I'm assuming I want to build this part flat like this, but at this point, if I don't want to build it like this, I can go in there and I can rotate it either using the rotation over here or come over here and put an actual angle in there. If I rotate it against the Y and put 45 in there. So now I'm below my build platform, I'd have to come over here and say 4 millimeters, get it up over.
Can you change these orientations as well? From
Yes.
the PSW?
Yep. Yeah, you can, but you really don't want to change. You can change the location on the build platform, but you really don't want to change the orientation of the PSW because any kind of support that you built,
Yeah, it's changed as well.
and if you go change the orientation, that support's not going to change. So at any point, okay, I decided, no, I don't like this. At any point, you can undo, and you can undo infinity as long as you keep the program open. You can undo and go forward too. So I'm going to go back to my original 4 millimeters. Sometimes I go in and I double check, make sure, yep, 4 millimeters. We'll get into more detail tomorrow on this orientation optimizer and comparer. Sometimes you may run into a situation where you have a part and you just don't know how to orientate it. Use the comparator or use the optimizer, and Magix will automatically orientate the part for you, which it feels is the best way. Might not be the best way, but it is going to do it in a way that it thinks it is. But experience tells you, once you get experience will tell you, no, that's not the best way. But in the beginning, it's very good to use it. So once we get the orientation like we want it, I go to support generation. What am I going to do? I'm going to generate support. On this particular part, I don't know why my Magix is a little messed up, but on this particular part, you will only have one support because it's basic, simple block. One surface is all we're using. So if you look here on my support list, if I had multiple supports, you'd see a list with them all. You only see the one with them, and it says block. Change the parameters on that is the page below it, support page parameters. You open it up. I know the hatching is not correct. It's supposed to be, default is 0.7. And if I say regenerate 2D, 3D, you're going to see my hatching tightens up, and that looks more like the correct way of doing it. A good rule of thumb is a 45-degree angle. Of course, it doesn't like that, so I got to come over here and tell it to and there's that little information button. Come over that anytime and you can see what it's telling you. And you'll see what happens, it's going to rotate the hatch in 45 degrees. 45 is usually a good rule of thumb, just leave it as default. If you notice, if I come over here to fragmentation and turn it on, the separation width is usually a good number, is whatever your hatching thickness is. It's good to put it there. If I say regenerate,
15 and 15, so it's basically going to change this to 15 millimeter blocks. So if you notice now, instead of having one solid block of support that you're going to remove, we're going to have a bunch of individual ones. A lot easier to remove individual ones than one solid block. You can also make it a lot easier too by turning on fragmentation on the border. Turn it on here. We'll have an interval of, we'll have 10 millimeter interval. Regenerate, and now you see I have fragmentation on the border also, which makes it a lot easier to remove. If you notice my teeth, I have no idea why it's got my teeth that big, but we can look at that. Again, you got A, B, C, D. You come over here and figure out exactly what A, B, C, D is changing when you change the numbers. 1.5 millimeters is way too much. I'll change that to 1.75. The C is the base length. That's way too much there. I'll change that to 1. B length is good. The interval 2 is good. Regenerate 2D, 3D. And you can see my teeth changing. And you can also change it on your borders. And there you go. That looks a little bit better. I'm going to zoom in here and show you what happens when you play around with some more stuff. I told you about that Z offset. You can see it's going in 0.25 quarter millimeter into my part. That's really strong support. So if I change that to 0, you can actually see it here. It's actually, let me out of that back into this. That there, and let me just show you. You got multi-section view here. We'll section view this in the Y. And here's where I wanted to show you. So now we're looking. We zoom out. I sectioned the part. You come over and you can actually play around with where you want to look at it. So now we're actually looking into the part, and you can see how deep that support is actually going into the part. It's going in there for quarter millimeter. You can watch what happens when I go to 0. See it actually, it's stopping right there. But if you remember stopping at the part, or if you remember what I said, in theory the laser is going through 3 layers, so it's still going 2 layers below, so you're still getting a good adhere. Check this, so put a negative number, so we're doing 50 micron layers. So let's say I put a negative 50 in there.
It's only one left.
Yes, so it's still going to go in your layers, because it's still hit. But what I wanted to show you is look what it's doing to your teeth. Somebody says this is like Batman, they call it. The Batman teeth. Which it kind of does. Once they told me that, I'm like, it kind of does. So what it's doing is it's basically putting these little points on your, and somebody looking at it like, man, that's very weak. But if you can get away with it, that's the kind of support you want, because basically you take a pair of pliers and you can just twist it, it's going to pop right off of there. That's what you want. And somebody also mentioned, have you guys ever walked in the woods and you got those burrs that have the 2 little hooks on them? And they're all over your pant legs. So they actually do a good job. It's kind of the same theory that these do. It really does hook into the parts really good. Now, if you don't put any teeth on, it's not going to do any of this stuff. So in the beginning, I'll leave that up to you guys. If you want to play around with teeth, or if you just want to make sure parts build, just don't use teeth. So if I come over here and turn teeth off, you'll see what happens. Teeth, I'm going to just, no teeth. Border. see, it did no teeth. And but your Z offset's still affected, so it just didn't go into the, there's no teeth, you're gonna have more surface touching your part, harder to remove the part. Remove the support from your part. So it's all up to you, and this is what I'm saying, you know, at first do you just want good parts and worry about cleaning them up later? Because you're not really, if you continue to have failed builds, you're not really learning anything. Because you don't have a part to kind of see what worked and what didn't work. So it's, you know, something that you'll have to discuss as a team. Hey, how do we want to approach this? Turn off the section view. So at this point here, this would be good to show this too. So I have this called a block. So here's the types. Here's all the different types of supports you can have. I can turn it to none. It's going to ignore that surface. It's going to put no supports there. I can change it to a point support. Puts one support right in the middle there. That's not going to work. Point support works great on lattice structure, for example. You're going to use point support. And then you can go in there and individually tell the points exactly where you want your supports. You can have a web support, line support, contour. I've really never seen too many people use these other supports. I've seen block, point, volume, which is basically solid. It's going to treat that as the same parameters as your part. So you basically you're going to have, you better have a wire EDM if you want to remove this from the build plate then, if you use volume.
The automatic tree, what does that look like?
The automatic tree. So I don't know if you guys have that. You might have to, that might be an extra module, but we'll see what it does here. So tree support, you basically want to use that lattice structures. It's made for delicate, lots of geometry. It's not a very strong support. So you'll see this basically pop up. You know, you're going to basically see like a trunk of the tree, and you're going to see a bunch of branches coming off of there, and they're very delicate. Basically need a brush blade, because if you, there's what it looks like. So if you didn't have a brush blade, picture this. See how fragile that support looks?
Yeah.
So if you didn't have a brush blade, you just wipe that away with the regular recorder. There is a setting in there, you can go in there and change the geometries, so you can have a thicker trunk. And then you can also add more branches to that too.
I should call it chicken legs.
And where that is exactly, like, you know, I haven't really played around too much with the tree support. But if I go back to block, you can see it changed my settings back to default, or back to whatever it thought was default. But you can go into cones. So now I've just done cone supports. You can change the cone here. You have a diameter at the top. You want a smaller diameter at the top than at the bottom, so it's easier to remove. And basically a cone support is solid support, but it's spaced a lot farther apart, so you can go in there and hopefully remove it a little easier than solid volume support. Sometimes cone support is great for putting right at the corners. So you may add a cone support right at the corner instead of, you know, at the whole bottom like this.
Which one you recommend to start with, switch
block.
Black, so.
Yeah, start with block, always use block. Block you're gonna use 95% of the time. And then the other 5% of the time, you may use a combination of putting some extra cones for extra support, or you may use a volume support on a difficult part. Titanium, for example, a lot of internal stresses, so you use a lot of solid volume support.
The solid. Yeah.
Solid's very different. If you use solid support, you have to have a wire unit.
Okay,
Just because it's
so hard to.
even a saw will take, it's gonna, especially if it's a big part, picture of a big part, and you got solid support back here. Depending on if you have a good saw, cheap saw, if you have a very good saw, yes, you go through that pretty quick. But if you have just like a
Man's.
cheap bandsaw, you'll be there 8 hours and you'll probably go through a couple blades. And at that point too, you might even scrap your part because the blades start walking and then it cuts into your part. You just achieve nothing then.
Flexible, we can use the.
Yes. So real quick too, I'm going to show you, you can do 2D edits. You come in here, here's basically what my support looks like. And I can come in here and change up. And as you see, where I cut, it removed that support. So you can go in there and customize your support. Lots of things you can do. And then I can go in there and add, special support into those areas. And the reason I showed you that is, so once you make a 2D edit, you want to say regenerate 3D. Because if you say regenerate 2D, 3D, it's going to go back to your default. That's kind of why I showed you that. So if I say regenerate, you see it doesn't change, but if I say regenerate 2D, 3D, it ignored my changes and went back.
I think the option is there, but it's not gonna work for you. Because still you need a space between them. I mean, in the middle. So
Yes,
you cut,
yes,
yeah.
yes. I just did that to show you as an example. Yeah, no, you wouldn't do that. Or maybe you would do that and you're gonna put some kind of custom support in there. And at any time, you can also go in and let's say, this is not a good example, but let's say you have a part, Magic says, no, you don't need support there because it's on a certain 45 degrees. It says no support is needed there. You can go in there and say, yeah, I want support there because I need that support there to help dissipate the heat. So, in that case, you're going to go to surfaces and you're going to create a new surface. So you'll mark that triangle, say create new surface, and then boom, it's going to put support on that surface. We'll go into, we'll have examples that we're going to, the sample parts I have, we'll be playing around with that. Because I'm just covering a lot of info right here right now. And then before you exit, you're going to want to do a, let me change this real quick. So before you exit, you want to export your support. You export it, you're going to want to, well, actually for you guys it doesn't matter.
Yeah, because we're just building.
Because we're going to do it in the build processor. That's right. Just trying to think if it does matter. But
Yeah, I don't recall ever saving it at this point.
yeah, I think for you guys it does not matter because you're using the build processor. But you do want to save, so we'll cancel this. You do want to save your part. I'm not going to actually save it, but it's So then at this point you can exit. It's letting me know, hey, you didn't save it, that's all right. Once you exit it, all support turns to blue. And you would be using the, oh, of course I'm in